Imagine a world where the rules of space and time are not as simple as they seem, a place where a fourth dimension of space exists, beyond our everyday experience. What would this mysterious dimension look like? And what would it mean for our understanding of reality? The fourth dimension in physics, time as a dimension. In Einstein's theory of relativity, time is treated as the fourth dimension, merging with the three spatial dimensions to form space-time. Space-time. Every event is defined by four coordinates: three spatial coordinates, x, y, z, and one temporal coordinate, t. Together, these dimensions provide a complete description of an event's position in the universe. Relativity of time. Einstein showed that time is not absolute but relative, meaning it can flow at different rates depending on an object's velocity and gravitational field. This is known as time dilation. For example, a clock on a fast-moving spaceship would tick more slowly than one on Earth. Space-time curvature. Massive objects like planets and stars warp space-time around them, which affects the motion of other objects. This is perceived as gravity. The more massive an object, the more it bends space-time, and thus, the stronger its gravitational pull. The fourth dimension in mathematics, higher dimensional space. In mathematics, the fourth dimension can be thought of as an additional spatial dimension beyond the three we experience. Although we cannot directly visualize it, mathematicians can work with it using coordinates and vectors. Just as a three-dimensional object has coordinates x, y, z, a four-dimensional object has an extra coordinate, x, y, z, w. The fourth coordinate, w, represents the additional spatial dimension. 4D shapes. The tesseract or hypercube is a four-dimensional analog of the cube. While we can't fully visualize a tesseract, we can represent it with a projection, similar to how a 3D object can be represented in 2D. Applications in various fields. Higher dimensions have practical applications in areas such as quantum mechanics, string theory, and complex systems, as well as in computer graphics and data science, where concepts of multidimensional space are used for data representation and analysis. The fourth dimension in philosophy and science fiction. Many works of philosophy and science fiction explore the concept of higher dimensions beyond our immediate experience. The fourth dimension in these contexts often implies realms or phenomena that exist beyond normal perception. Parallel universes and alternate realities. In some science fiction stories, the fourth dimension is depicted as a gateway to alternate reality or parallel universes. For instance, characters might enter a different dimension where the laws of physics are entirely different. Time travel. The idea of time as a traversable fourth dimension is also a popular theme in science fiction. Stories like H.G. Wells' The Time Machine explore the idea of moving freely through time, much like we move through space. Higher consciousness. In philosophical discussions, some consider the fourth dimension as a metaphor for a higher level of consciousness or existence beyond physical reality. Here, the fourth dimension symbolizes an aspect of reality that humans cannot perceive directly, but might be able to understand through spiritual or intellectual growth. Exploring the fourth dimension through projections and simulations. Although the fourth dimension is challenging to visualize directly, various techniques help us understand it. 2D and 3D projections. Just as a three-dimensional object can be projected onto a two-dimensional plane, e.g., a 3D object casting a 2D shadow, a four-dimensional object can be represented as a three-dimensional projection. The famous hypercube projection, for example, illustrates what a tesseract might look like in three-dimensional space. Virtual reality and computer simulations. Advances in VR and computing have made it possible to simulate higher dimensional spaces, giving us a sense of navigating within four-dimensional environments. These tools help researchers, mathematicians, and even artists explore complex shapes and dimensions in innovative ways. Applications of higher dimensions in modern science. Higher dimensions are not just theoretical curiosities, but have practical applications, especially in advanced physics and cosmology. String theory. One of the most famous theories involving higher dimensions is string theory, which proposes that the universe operates in 10 or 11 dimensions. While we experience only 4, the other dimensions are thought to be compactified or hidden at subatomic scale.